Hello, everyone. This is Rona Palmer from eMaint Enterprises. Thanks for joining us today for this month's Best Practices webinar. And I'd like to start by clarifying today's webinar. Since eMaint is a software provider, we provide a whole host of trainings online, including product trainings and product demonstrations. But our Best Practices webinar series is a bit different, and here we focus on maintenance strategies, inviting speakers from different industries with different backgrounds who really offer complementary products or services to share their knowledge. And I'm always pleased when we have someone from our own eMaint family joining us. And so today's session is going to focus on ISO 14224 and considerations for a CMMS. And I'm pleased to have with me Roy Rothwell, our guest speaker. And Roy is a senior consultant in our professional services team, and he's going to be presenting today's topic. And Roy, thanks for joining us today, and thanks for putting this webinar together. I know it's the first time we've presented this topic, and maybe you can start, Roy, by telling our listeners a little bit about what prompted you to want to pull this particular material together and share it with our audience today.
Sure, Rona. Good afternoon, everybody. Yes, this particular topic, it comes up regularly when we're interacting with both prospects and our customers. The topic, it's all around collecting data and data in relation to reliability and maintenance. As we go through it, we'll see that it's not specifically for the oil and gas business. It's very applicable to anywhere there's a maintenance technician. So yes, the topic comes up regularly. We've got some customers who've actually taken the standard on board and are implementing their CMMS in alignment with ISO 14224.
Excellent. All right, well, before I turn things over to Roy and get on with the presentation, a few quick housekeeping items I'd like to cover. We are recording today's session, so I have all of the attendees today on mute so that we can get a good quality recording, and we'll be sharing it with all our listeners at the conclusion of the webinar. And we're also, Roy has agreed to provide you with a copy of the slides, and we'll have a survey at the end of the webinar where you can indicate that you'd like to receive the slides. But also, Roy has agreed to answer any questions and to stay for the full hour and answer your questions. So please go ahead and type your questions at any time during the presentation into the questions box and go to webinar. And then I will ask them of Roy at the conclusion of his presentation. So at that, Roy, I'm going to turn things over to you.
Thank you very much, Rona. Good day, everybody, wherever you are in the world. Today I'm speaking to you from the eMaint offices in Dublin, Ireland, where the EMEA headquarters of eMaint is located. Here in the office in Dublin, we have got the resources to assist all areas within the eMaint business in relation to sales, services, product development, and customer support. For myself, I'm involved in the implementation of the eMaint product, so I spend a lot of my time face-to-face with our customers on the road and also remotely as well. I've been involved in the implementation of computerized maintenance management software since 1989 in relation to implementation of projects in the oil and gas business, FDA regulated, transport, semiconductors, and facilities. As I was just saying there in my opening remarks with Rona, you know, the topic of ISO 14224 comes up as we engage with our clients and our prospects, certainly when it comes to the data side of setting up a computerized maintenance management system. We've got quite a hefty slide deck today. It's quite difficult, I guess, to take a standard and visualize it in a slide deck. So I've done my best to take what I can from the standard so that we can go through it in terms of a visual today. So it's quite hefty, and we will certainly share this with you folks after the session today. A little bit about the context of the agenda today. We're going to have a look at overview of what the standard is about in terms of context. We'll have a look at the main objectives of what the standard is trying to achieve. What value does the standard add to an organization? Some tips and tricks about adopting the standard within your organization. For me, the core of the actual standard is within what they call the annexes. So we're going to have a look through 3 or 4 of the key annexes during this webinar today. And we're going to finish off by seeing how ISO 14224 fits in with the implementation of a CMMS. And along the way, we're going to have a couple of polls and to see how the standard fits in with your views. And it'll also help provide a little bit of a context setting for me as we go through the presentation. So a little bit of context setting in terms of ISO 14224. Well, I guess like most projects and processes in the world of CMMS, there are a plethora of terms and abbreviations out there. I always like to show this particular word cloud or something like it because the CMMS world is characterized by acronyms. So this particular word cloud, it talks to all of the different terms and references that we've got going on there in our world where 14224 plays in. So OEE, CMMS, reliability, reliability-centered maintenance, OpEx, work orders. For some of you folks stateside, SMRP, and the equivalent in this side of the world. And some of the FDA-regulated terms like 21 CFR Part 11. So all of these abbreviations play into the world of CMMS, and ISO 14224 is no different. I also like to show a little bit of context in terms of the journey of most organizations in the rollout of a computerized maintenance management system and the types of topics, strategies, standards that potentially would come into play. I've got ISO 14224 in green there today. The arrows that are there in orange may well play into what we might call the building blocks for the successful implementation of a computerized maintenance system. Alongside that, though, and dovetailing with it, are potential asset reliability strategies. So, they could be OpEx, could be total productive maintenance, it could be something in the spares world, an MRO initiative, it could be FDA regulated, 21 CFR Part 11. But ISO 14224, it certainly plays its role in relation to the setup and even the ongoing continuous improvement of a computerized maintenance management system in relation to equipment and in relation to asset reliability. I also like to show what we call the typical CMMS environment. This particular slide gives a perspective of the key functions in terms of the implementation of a computerized maintenance management system. We look at topics like corrective maintenance, preventive maintenance, inventory purchasing. Also here, the various players that the implementation of a system like eMaint can assist with and who those players might be. So look at the day in the life of the roles of those particular players. The CMMS administrator, the technician, the engineer, the reliability guy, the planner scheduler. The setting up of a CMMS and the data as it's being set up are where ISO 14224 comes into play. The phraseology is taken from, even if we go to look at Wikipedia, we'll look at some of the terms that influence the implementation of a CMMS and the data in relation to it. So the messages in even what Wikipedia have to say about this. The collection and exchange of reliability and maintenance data for equipment. I'm not going to get too hung up on the fact that it came from the petrochemical and gas industries. This particular standard is most certainly applicable across all industries, and particularly all industries where a CMMS comes into play and can be used. A quick search in Google presents us with these sort of illustrations. You can certainly see an oil rig in the middle there, and certainly influences coming from the oil and the gas industry. Also there we can see triangles. There's 3 or 4 on this particular slide. So what's with all the triangles? We'll have a little bit of a look at what the triangles mean a little bit later on in the webinar. We'll go into it in just a little bit of detail. But it's the one illustration from ISO 14224 that really assists, particularly assists in relation to the setup of the data. So I think, look, Rona, if I can hand it over to you, I think we've got our first poll coming up. So maybe I can pass it over to you to take a look at the poll.
Sure. So today we'd just like to get some feedback to you before Roy gets too far along in the webinar. Can you describe for Roy your current understanding of ISO 14224? Just let us know, do you already have a good understanding of it, or perhaps you've heard of it, but you really don't know how it benefits your organization? And for some of you, you've never heard of it, so you're kind of interested in learning more to see if it might have application for your CMMS. So again, there's these answers will just be shared in aggregate, so no wrong answers here. And it looks like we've had about 3/4 of the votes in, so let me give it a few more seconds. And alrighty, I'm going to go ahead and close and share the results here. So Roy, it looks like 9% of the people on the line have a good understanding already of ISO 14224. Perhaps they want to just pick up a few more tidbits today. 39% say they've heard of it, but really don't understand how it benefits them. And then 52% haven't heard of it, so they're just getting started and intrigued to learn more. All right, back to you, Roy.
Excellent, Rona. Thank you very much for that. Thank you very much, folks on the line. So looking like, you know, not far off 90% have either heard of it or have never heard of it. So hopefully I can shed some light on the topic today and clarify a few bits and pieces in relation to it and help you to influence your CMMS implementation as a result of this topic today. A few more other bits of context in relation to this. You know, I see ISO 14224 dovetailing and fitting in with the various strategies that could potentially be in play within the rollout of an asset management system. I like to think about ISO 55000, which is out there, a very, very useful overarching standard in the asset management space. You may well be familiar with Uptime Elements, the CRL program, and also the Society for Maintenance and Reliability Professionals in the US, the equivalent in Europe. But the context in relation to these strategies, I feel, you know, dovetail very well with ISO 14224, particularly in relation to setting up your CMMS. So this is where we find our key stakeholders are operating, and hopefully ISO 14224 will play into them. Just a quick note here on ISO 55000. The big picture is this illustration here. On the left-hand side of the illustration here gives the impression of sort of a chaotic world. ISO 55000 tries to address that chaos and turn it into a planned, coordinated world. And 14224 can definitely assist over on the left-hand side there in terms of CMMS setup and data and reliability information. Within the ISO 55 standard, there's a clear section around asset setup. It's section 6 within the standard that specifically refers to setting up of asset information and so on, and the value of asset information. So might be something to have a look at if you're on the ISO 55000 journey. In relation to uptime elements, the Uptime Elements illustration has changed recently. However, what I would say is that there are numerous elements here within this particular illustration where ISO 14224 can play in. Certainly in the middle there in the blue, where we've got CMMS, that's certainly a place where ISO 14224 plays in. OpEx in the leadership space, in the green space there, the area around even vibration analysis, and in the orange there on the left-hand side, topics around root cause analysis and failure analysis are certainly areas that 14224 can play in. Quick note on SMRP and EFNMS. This is the European Federation of National Maintenance Societies. So Pillar 3 in the SMRP world around equipment reliability is where the key touch point is here between SMRP and 14224. So the bullet points outlined there are going to be very similar to some of the items that we're going to see later on in this webinar, particularly in relation to KPIs, calculations, and reporting. So the sort of reports, the sort of KPIs we'd expect to see out of a system like eMaint and a CMMS are the sort of topics that we're going to be touching on certainly in one of the annexes later in this webinar. So the key objectives of the standard. So it's up there, it's international standard, and in the title, the collection and exchange of reliability and maintenance data for equipment. A little bit there in French. This has come from, I think, a standard that we got a hold of ourselves here, and the main point here is that it's applicable not just from the petrochemical and the gas industries. It's applicable across the board. Anywhere there's a maintenance technician interacting with a CMMS, interacting with data and reliability. The key sections of the actual standard, like most standards, I'll quickly run through them here. There's a scope up front, some references up front. Key sections around terms and definitions, very, very useful. Similarly, in the abbreviated terms section, how the standard is applied, and the benefits of reliability data and the exchange of that data. Sections also on quality of data. It's a topic that is on our radar all the time. Quality data over quantity of data. Very, very useful sections around what are called equipment boundaries, taxonomy, and definitions of time. We'll have a look at those sections in a little bit of detail a little bit later. And some recommendations in terms of, data failure and maintenance. As I mentioned earlier, the important pieces for me are the illustrations and the content of the various annexes within the standard. We'll have a look at some of them in detail, but equipment classes and attributes, how we deal with failures in the maintenance parameters. We'll have a look at calculations and how useful they are and how there's consistency in that area. The KPIs and benchmarking and classification, particularly in relation to safety critical items there too. The key themes that run through the standard are noted here. Safety, reliability, cost. There's an emphasis on cost-effective design and maintenance, data on failures, failure mechanisms. Maintenance is important. Methodologies and risk, reliability, data, the collecting of data. Data is an investment, is mentioned there, second or third from the bottom. It's an investment in the success of your organization, in your facility, and in the success of your CMMS. And clarity as to the causes of failure is key to prioritizing and implementing corrective actions that result in sustainable improvements in availability, leading to improved profitability and safety. So, you know, there are quite a few themes that run throughout the standard like that. But for me, you know, the standardization of the data collection practices facilitates the exchange of information between relevant parties. So plant owners, manufacturers, contractors, and so on throughout the world. So consistency of the data, a standardization of the data, extremely useful. What I would also say is that the standard 14224 it uses a phrase called the reliability thesaurus. I like that particular term. It's such a good reference document, particularly when it comes to references and terms and phraseology that we use in our world, the world of CMMS, the world of implementing CMMS, and taking advantage of standards along the way. Some of the items that are just noted there in orange, you know, it's an international standard, certainly assists as a standard format for equipment in all facilities, not just the gas and petrochemical world. Clear focus on data quality and assurance practices, and also useful in terms of the data collection practices that might come into play. We find this all of the time. You know, one of the very first key foundation stones of a successful CMMS is the data collection phase. And standard processes in relation to that, we do our best to implement a standard process for most of our prospects and our clients. Some topics within the standard around data categories. We'll have a little bit of a look at those as we go through the next few slides. But categorizing data is particularly around equipment, and there's a term there called equipment taxonomy we'll have a look at. It also looks at failure data, failure causes, failure consequences. What happens to a piece of equipment, and how can we categorize what's happening to a piece of equipment so that we can influence some decision making based on the causes of failure and the consequences of those failures. There's a focus on data usage, focus on reliability and data used in reliability, data used in availability, data used in the terms that we use, corrective and preventive maintenance. And also a focus on safety and the environment and risk. Another cloud here specifically related not just to CMMS, but in this case to 14224. There are dozens, maybe hundreds of definitions in the standard that are useful. You know, what we mean by equipment types, what we mean by a non-critical failure, what we mean by availability, what we mean by the life cycle, maybe what we mean by mean time to failure, mean time between failure. So definitions around these phrases and words that we use every day in the maintenance world, definitely very useful. So there's numerous pages in the standard that assist in describing this. So this reliability thesaurus and the common language that we want to use certainly clearly defined in the standard. How useful is the standard? Well, high level list here really of where 14224 can come into play in terms of the users. So, you know, those involved in the installation of plant, construction, those involved in the owning and the operating of those facilities. Industry, it's a cross-industry standard, very, very applicable across the board, useful for manufacturers and designers. You're going to see some illustrations of maybe some P&ID type illustrations as we go along here. You'll see where it comes into play for designers, particularly in the commissioning, maybe pre-construction phase of projects. Regulatory authorities and regulatory bodies find value in this as well, and contractors, consultants, folks that are involved in construction of facilities and installation ownership. So across the board, folks that interact with facilities, production, manufacturing, or otherwise. So it's useful across the board. And we're just going to hit a little bit later on, some terms that come into play and tend to cause maybe sometimes conflict, really. The topic of times, downtime, uptime, ownership of equipment when maybe a piece of equipment is down or unavailable. Definitely great document here to help us put some clarity around what all of those different phases of downtime might be. So we might have a little bit of a look at those a little bit later. So it brings us on to the topic really of, availability, reliability, and unreliability. So it leads us on to our second poll on the topic of reliability. So maybe I can just hand it back over to you there, Rona. Just a quick question on reliability.
Certainly. So again, this will just be, we'll just share the results in aggregate, but why don't you tell us and Roy, what is your biggest challenge today in your reliability journey? Is it having the sufficient budget to make the improvements you'd like to make? Or is it really battling with equipment downtime and understanding the causes? Or perhaps it's that you currently don't have a method of properly collecting data and analyzing it. So why don't you just share what's your biggest challenge? Pick one. They might all be challenges, but maybe one will be the biggest, and we'll see how you fare relative to the rest of our listeners today. All right, we have quite a few people on the line, so I'll leave this open a few more seconds, let everyone cast their vote. All right, let's go ahead and share the results. So it looks like 32%, or roughly a third, say budget is really a challenge in their journey, Roy. 18% say downtime is their greatest challenge. And interesting, 50% say that they don't have a method to effectively collect data, which I know is part of what you'll be talking about today and how this standard applies. All right, back to you.
Very good, very good. Thank you very much, Rona, and thank you very much again, folks. So, for the numbers that we see on the call today, 50% no method for effectively collecting data. This standard and the next little while is going to really help in relation to that. For those who are focused on equipment downtime and the challenge there, let's have a little bit of a look at the reports and the KPIs that can come into play in relation to that. In relation to cost, certainly an area of focus in one of our earlier slides, the role of the reliability engineer to be able to have a look at reliability improvement exercises and projects. Very, very important to be able to delve into where the money is being sunk in terms of unreliability. So, to that, what value does 14224 add? Well, up front, economic aspects. We talked about cost a minute ago in terms of the challenges there. So it certainly adds value in relation to that. So cost-effective design, whole life cycle cost management. If you're lucky enough to be in the early phase of an operation or a project or a construction, you're in the right space to be implementing 14224 in the context of a CMMS. safety and environmental aspects, and analytical aspects. So across the board here, lots of bullets where ISO 14224 can come into play and add value. Into the nitty-gritty of the actual implementation of 14224 within your organization. Just got a flow here, gives you a flavor of an illustration that's come from the standard. Typical feedback of analysis from the collection of reliability and maintenance data. So we talked just a little bit there about, the life cycle, I suppose, of a facility, design, manufacturing into operation and maintenance, but then as time goes on to capture the failure and maintenance events. And we like to use what we call the Deming model there, plan, do, act, check. So that flow certainly feeds into that, and no better place to be able to capture that information than in a CMMS. So plan, do, check, act, using a CMMS within the context of the ISO 14224 adoption model. Back to those triangles that we saw early on when we did the Google search. So what's that all about? Well, it's all about what we call the taxonomy. So taxonomy in relation to 14224 is really core in terms of the usefulness of the standard. When we engage with our prospects and our customers, the topic of data setup is paramount. And in terms of the quality, it's critical. In this illustration here, the upper tier of this 9-tier triangle stroke pyramid talks about where equipment is located, the location of equipment and the high level use of equipment. The lower tiers from tier level 6, 7 and 8 talks to what we call equipment, assets, or even what I like to call the maintainable item. So we have the conversations with our clients around, what do I raise a work order on? Well, a work order could be raised on any of the levels from 8 up through to 1, but primarily levels 6, 7 and 8. It's talking to the equipment subunit or equipment subdivision. And level 9, for clarity, is what we would call a part. So a reusable part, a disposable part, a part that's held in a storeroom, or a part that's purchased for a work order in the repair or replacement of an asset. So Taxonomy Baby, that's where it's at. And it's a core, fundamental, critical element of the 14224 standard. Most clients that we have that engage with this find this the most useful illustration in the standard. So details as to what each of those taxonomy levels look like and how they're described and how they're defined. So levels 1 through to 9, very, very useful. Helps us to define what we're talking about. So, from industry down through business category, right down through subunits. Level 8, what do we call a component or a maintainable item? And level 9, what do we call a part? And some descriptions and definitions of each of those. We find that as we set up our computerized maintenance management system, that these taxonomy levels typically come into play as we set up our assets. So, and you'll probably find that in most of your CMMSs, whether they're eMaint or not. Another topic that comes into play as we set up our system is the term typically used in the US is what's called the hierarchy, or family tree of how data is put together. Parents and children and grandchildren and great-grandchildren and siblings. So there are numerous ways of connecting asset data together, particularly within a CMMS. ISO 14224 talks about 5 particular structures. They call it architecture, but you can see from these different models, there are various ways of connecting data together. So, an asset can be part of a family tree, but it can also be part of a system. It could be part of a network, and computerized maintenance management systems these days are, relational database systems. So the relational model definitely comes into play and assists in that regard. Just a quick image there of what maybe, what you might be familiar with in terms of a data structure. So, when assets are put together, we might have them put together in a hierarchy like this, but terms that come into play now are terms like how do we deal with the asset data. We're starting to look at phrases and terms like preventive maintenance, corrective maintenance, failures. So that's what the logical data structure might look like for an organization like yourselves. The terms that come into play in terms of our maintenance strategies are mentioned. Activities before a failure, so preventive maintenance, condition-based maintenance, condition monitoring. Terms that come into play after a failure, corrective maintenance, urgent, deferred, and so on. So these are sort of phrases and terms that are starting to be seen now in 14224. So definitely really giving a perspective that this is a standard for everybody, not just for the oil and gas business. Coming in now to the annexes within the standard, which for me are very, very useful. Annex A, equipment class attributes. What this is about is it's taking us through how we might go and codify equipment in a system like a CMMS. How do we describe equipment? And in this illustration, in what's called table A4, we've got what are called equipment classes. So the actual standard outlines many, many, many different equipment classes, dozens of equipment classes. And in this case, we're looking at how we would describe a compressor using codification within the system. So CO for compressor, EG for electric generator, EM for electric motor. So if we're looking at, and we have this question asked of us all the time, Roy, when we're putting together an asset identifier, where do we start? So my response is typically use an equipment class in the acronym or in the abbreviation for your asset. It helps to describe what the asset is, and it also helps later when we get further into reliability and failure connectivity. In the standard, there's a definition for something like 125 different equipment classes. So very, very useful for those 50% of the people that are on the line today who need help with setting up your data in a CMMS. Equipment classes then broken down in table example A8 here, where we break equipment classifications down into further equipment types. So in this illustration here, we're breaking down compressors into centrifugal, reciprocating, screw, or axial. So we've got what are called equipment types. So equipment types, equipment classifications, certainly very, very useful in those appropriate and related illustrations and tables within the standard. I also mentioned earlier in my opening remarks in relation to design and the maybe potential P&ID drawings. So here's an illustration. For most of the equipment types and equipment classes within the context of the standard, there goes with it what we call a boundary definition. So in this example here, we're looking at the boundary definition for compressors. Not far off the image of a P&ID drawing, we can see, valves there. We can see, starting system, lubrication system, all the different ancillary elements in relation to compressors. But for something like 125 different equipment classes in the standard, there's associated 44, 45 boundary definitions. So the meat of the standard is within the context of equipment classes, equipment types, and these boundary definitions that gives us great illustrations of the construct of the physical facilities equipment potentially within your organization. So that's Annex A, very, very useful annex. It takes up the bulk of the standard. Annex B. Annex B talks to failure and failure parameters. Within this particular annex, the subject matter talks about failure types, failure mechanisms, failure causes, failure modes. So just a quick list here of potential failure types that could occur across the equipment classes within your organization that you would be using a computerized maintenance management system to manage. So it's really all about the processing of work orders and taking advantage of the intelligence that we capture as we're processing work orders. So as a technician is closing out a work order, to be able to capture the failure information on the asset that is a corrective maintenance or a reactive type activity. So the failure type comes into play. Failure mechanism is what's contained in table B2. Failure mechanisms are examples outlined here. So for the various failure mechanisms, there are then subdivisions of failure mechanisms. So in this illustration, we're talking about a potential mechanical failure. And then what type of mechanical failure did occur? So we've got these codes and notations for the mechanism, and then we've got subdivisions for each of the failure mechanisms in play. So great illustrations again, great tables of data to help us as we're recording what issues occurred as we're processing work orders in terms of failure information. Failure causes. The standard helps us here in relation to what caused the failure. So as we're capturing work during our work orders and closing out and completing work orders, we can capture failure causes. So there are categorizations of failure causes noted here. So the failure causes are presented in table B3 within the standard. And again, some examples in terms of the notation and subdivisions of the failure causes. And they can be broken down into the various subdivisions as you can see there in table B3. Failure modes. It's an area that comes up with lots of our clients because as we get into the business of computerized maintenance management and reliability, the topic of failure modes, what's the appropriate place to capture what a failure mode is? How do we know what a failure mode is? What education do we need? What referencing do we need to be able to categorize appropriately failure modes in the context of processing work orders? So in this case, there are typically failure modes associated with classes, associated with categories, and we can capture them from the failure modes tables outlined within the standard. So table B15 is an example here of the types of failure modes that could occur, and failure modes are typically going to occur against equipment types, equipment classifications. So the failure modes associated with motors are going to be different than the failure modes associated with boilers, are going to be different than the failure modes associated with pumps. So categorizing failure modes related to the appropriate asset and equipment types, very, very useful. Annex C, reliability and maintenance parameters. This is an area where we're looking into the mathematics behind what reliability might mean to you. So just a quick note here directly from the standard itself. You know, there's a whole area devoted within the standard here, Annex C, in relation to the mathematics of reliability. And here's a discussion around the mathematics of availability. So as I meet customers and prospects, there's always a debate about availability and reliability. So this particular annex helps to clarify and clear up any ambiguity about what availability is. And if you're interested in the mathematics of this, there's quite a substantial section in the standard that will help you here. So as I was going through the standard myself, I started remembering my old college days when I was studying to be an engineer, and the sort of topics that came up there. And I'm afraid my mathematics didn't help me too much these days. But certainly, if we're looking at putting together a formula for working out mean time between failures or mean time between to repair, all of those particular formulas and calculations are available within the standard. And we would then potentially use some of those calculations as we assist our clients in putting together reports and KPIs to enable information to be captured, to turn information into reports, to help improve reliability and availability in the world of maintenance within the context of our CMMS. The famous bathtub curve to assist us with planning strategically the maintenance activities around our assets is presented within the standard. So, you know, what does the failure rate mean? And for those with experience in reliability and reliability-centered maintenance, you're going to see, I believe, 6 different bathtub or curve types within that particular strategy. So here's an example from 14224, but the point is that the calculations for assisting with what the failure rate might be certainly used within the context of putting together calculations for the bathtub curve and any other reliability information illustrated within Annex C of 14224. And if you want to go and use the Bayesian approach for estimating the failure rate with 0 failures, here you go. Be my guest and let me know how it goes. Within the context, from a very serious perspective though, folks, the consequences of failure as a result of a piece of equipment not being looked after or not being taken care of properly is something that comes up in our world all the time. As we're putting together the matrix of asset criticality and work order importance. So to be able to get to a level of granularity so that we can say, okay, what's the most important work order to be tackling today? We find that this table here, table C2, assists greatly in that regard. If you're familiar with Roman numerals, there's numbers here between 1 and 16, top left to the bottom right. The most important, urgent, catastrophic issues are what's categorized as number 1 there. The least important and the low maintenance cost items, minor, non-urgent operational type issues are bottom right-hand corner, number 16. So if you want assistance in prioritizing your assets and prioritizing your work orders, you won't go too far wrong by using Annex C in the standard, certainly for prioritizing work and giving you a perspective of what was done, what importance was that work, and most importantly, and reliability-centered maintenance strategies will bear this out, what were the consequences of the failure? And this system here will certainly assist in that regard. Your numbers may be something like simple, like 1 to 4, or something a little bit more elaborate, like 1 to 16. But in any case, the illustration here in this table is certainly going to assist you. Coming towards the end, KPIs and benchmarking. Every client that we interact with in terms of using a system, computerized maintenance management system, are looking to take advantage of reports from a system. What 14224 does is it helps you to understand what are the most appropriate KPIs and reports in this world of operations and maintenance and reliability. So what you'll find in a system like the eMaint system, or most good CMMSs, are a suite of reports and KPIs that are going to help you to improve reliability, maintainability, manage work, manage people, manage your backlog. So Annex E in the standard is what talks to this particular topic. And also, you're going to find something similar in the SMRP pillars and the related KPIs and reports. So there's going to be a crossover in terms of what those reports look like and those KPIs. The previous version of the standard had something like 18 or 19 KPIs reports proposed and the definitions of what they were. This particular version from 2016 of the standard has 34 reports and KPIs proposed. I've just got a couple of examples here from the standard. So the very first one up on the list is METBF, mean elapsed time between failures. It may not have made itself known in the previous edition of the standard, but certainly it's hitting the list at number 1 right now and in this current version. MTTF may well be familiar to you, mean time to failure. It's an acronym that's been around for a while. MTBF is another one that's there. So if you're looking for a definition and an explanation as to what these core KPIs are, Annex E within the standard is where it's at. There are 34 KPIs reports described within the actual standard there today. So very, very useful. Those various KPIs and reports cross the board of all of the different areas that we're interested in terms of rolling out a CMMS and in our world of reliability and operations management. Those are the key areas, folks, within the implementation of ISO 14224, right? To bring it back to how it connects up to a CMMS, and particularly a good CMMS like the eMaint product. But where does 14224 fit in? Well, if we look back at this typical CMMS model, the environment here, the reliability thesaurus that I mentioned earlier certainly assists across here in terms of the terms that we use, the terms that we might be familiar with, the common language within the world of CMMS. It certainly assists in terms of data preparation, those triangles that were there, the taxonomy, the hierarchies, the relationship. It assists most definitely with data categorization. So they're right in center of that particular illustration at the top. When we're setting up our assets and our parts within the system, that's certainly core. And then down the left-hand side there, I have a couple of illustrations of graphs and charts. That's where the KPIs come into play. That influences the day in the life of the technician and the supervisors on the day-to-day work and the planning and scheduling of that work. And down towards the bottom, the KPIs and reports that assist from a trending perspective, monthly, quarterly, annually, to give us a perspective of reliability and cost and all of the other strategies that we may well be trending. So certainly 14224 fills all the gaps that this particular illustration of the environment might present to us. We also like to talk to what we call the 10 keys to success, the keys to success in the implementation of a CMMS. And I've just highlighted two of the major areas here. Maybe I'll look at number 7 first, which is around, data population and validation. So clean data, quality data, understanding, what the data context is, asset types, asset classifications, failure information, how we put it all together. And what I would say a standard operating procedure for the setting up of your CMMS and for maintaining your data very, very useful there. So in terms of the 10 keys to success, ISO 14224 most definitely plays in there. Again, a final look at the journey, you know, slap bang in the middle there, ISO 14224 for me is certainly something to be aware of, take advantage of, and don't be a bit afraid to download a copy of the standard from the ISO website. Just a quick image there of, you know, the ISO 14224. That's what it looks like when you go to the ISO standards website. We're over here in Europe. It presents itself there as 198 Swiss francs. Don't worry too much about that. I'm sure your local dollar value or whatever currency you wish to purchase in, it will be presented to you. But what I would say is, you know, thank you to the ISO standards for providing 14224. Definitely assists in our world. Just a quick shout out to my colleague, friend, Greg Perry, based in the US. Greg assisted me in putting this material together, and Greg talks to this particular topic day in, day out as he's interacting with our customers and our prospects. So thanks to Greg, he's an expert in this area, and thanks for his assistance in putting this material together today. With that, Rona, I'd like to say thank you to everybody on the line. Thank you for looking at the material today. Now it's open for any questions.
All right. Thank you so much, Roy. I really appreciate it. We have time for a couple of questions, so please go ahead and type them in. If we don't get to all of them, I do promise that we will try to get answers to you after the session. And also, we've had numerous people ask, there's such a wealth of material covered here today that people are going to want to refer back to. And when we conclude the webinar, there'll be a survey where you can indicate that you'd like to get a copy of the presentation, as well as we'll also share a link to the recording. One person did ask about, for clarification on the classification and boundaries, Roy. When you're dealing with a system where you might have to do a high-level PM, in this particular case it was a sanitation PM, that includes so many different systems, valves, pumps, etc., that all have to be done together. In your experience, what's the best way to set up that type of classification system to allow for those types of PMs that cross different systems?
Very good. I've put up here this slide that I think best articulates the challenge that's there. Because I guess in that particular scenario, we're talking about equipment that might be constructed in a hierarchical model. We probably also want to consider other potential models as to how information and data is connected. So if we've got a PM on a multiple of assets, but they may cross over different networks or different families or different family trees or different key major assets, think about maybe grouping that particular bundle of assets in another way. Within our product, we have various features for grouping assets together that may not necessarily be connected in any of these 5 models that are presented within the standard 14224. But because a system like eMaint and similar CMMSs are put together in what we call relational models these days, it's not that difficult to put a connection together so that you can connect assets that may be disparate together into a group. That's what we would do within the eMaint product, and then set up PM schedules then that relate to that group of assets that might otherwise be disparate and disconnected.
Very good. And someone is also asking about 14224 doesn't give specific direction on building your asset hierarchy using a smart numbering versus auto-generated classification system, numbering system. In your experience, do you have any rules of thumb about what system you want to use in which context?
So there are, in my experience, two two rules of thumb. In terms of creating what you might call an asset number, the use of an automatically generated number can be useful. I often think of the registration number on my car. It doesn't really matter what the registration number of my car is, except that it helps when it comes to taxing the car or insuring the car or knowing who owns the car. What I would also say is that if we build too much knowledge or too much information into the asset ID, then it could become an issue for us if the asset happens to move. So if an asset moves, be careful of including maybe locations or additional equipment detail into the asset ID. So if I go back to this Taxonomy Baby slide, just to be careful of the elements that might be included in an asset ID. I always like and guide our clients through using the combination of an equipment class or equipment type to help define the fact that it is maybe a reciprocating compressor. So maybe include the code CO and RE in addition to maybe some random number. After that, we can then connect up PM schedules, tasks, and so on, because we now know that we're talking about compressors, and that follows through then into the reliability side of the house when we're connecting up failure information and failure modes. So ultimately, with the end in mind, we're always thinking about reliability of the asset types, and that's where the connectivity between setting up assets up front and the failure information as we're processing our work orders comes into play. So we can always then join up reliability with the assets as we're setting them up.
Excellent. Well, thank you so much, Roy, and thank you to our listeners. I'm sorry we couldn't get to all the questions, but I do want to be respectful of everyone's time, and we're at the top of the hour. So thanks again for joining us, and let's not end the dialogue here. At the conclusion of the webinar, we're going to share a survey. Please let us know, how did we do? What other topics would you like us to see in our best practices series? We'll also make sure we have requests to also cover different topics for those of you that are eMaint users, been asking, how do we apply this to eMaint? And please be looking for our other web workshops where we show you a little more of the how as opposed to the why. But thank you, Roy, for kind of sharing your experience and putting this deck together and kind of showing us how this standard can be referenced and be applied. And thanks to our listeners, and we'll see you all the next time. Take care.